Hi, it's Gadget UK here again on the back end of the CD32 FMV module repair video. I thought, let's recap this. I've been putting this off for a number of years. Got a cap kit here from Retro Bench that's sadly no longer with us. You can see how dusty it is. Yeah, a full capacitor kit here. I'm just going to fly through this because I've done recaps on a few of these on my channel actually. Maybe two, I think. One we did in a live stream, and I think I did one for Mainmeister. So yeah, I'll fly through this and we'll perhaps, I don't know, have a look at a few of the things within this video as well. So 5 screws on the underneath. I already undid these for the purpose of working on the FMV module there. So it's easy to lift that side up like that. This side, however, is a wee bit harder to get to. Pliers may help you, but the shield is right in the way. So I tend to just get something pressed onto the side of it and just sort of try and pull upwards and into it as I do that, and then hopefully it should be lifted up and come out like that. And then we've obviously got this JST here. Put that out of the way. And obviously, because I've been working on the FMV module, we'll just carefully disconnect that if we can. Yeah, it's easy just to pull the thing out of the back and get rid of that as well. And then from memory, there's just 3 screws. I think you've got one down there, one here, and one over there. Right, those 3 screws are out, so let's see if we can now sort of try and lift. I think the shield comes off first, doesn't it? Oh, and of course, you've got to bend these. Probably going to break off. And I was thinking about this. I might actually leave this shield off. That one's nearly broken. I can feel it. It's nearly broke off. I can feel it just hanging on there. Although the shield over here sort of holds the bay up, so you know, any modules you stick in here, they sort of hang down on the shield. So might have to put that shield back in. Anyway, you can see it's pretty clean in there. I don't see any signs of capacitor leakage from this distance. So we'll try and lift this out now. It's not screwed in, is it? I don't think. Yeah, a wee bit fiddly to get that out. The shielding grips here at the point where those 3 ports are. Be careful not to cut yourself when trying to get this out. You can see I'm just like poising a little bit there. There we go. There's the motherboard out. Yeah, and we do have a little bit of corrosion around this area here, actually. That's a component there, not sure you can see. It just looks a wee bit green around here. So 1 or 2 of these have perhaps leaked, and obviously this is right next to the CD stuff here. Well, I think. So yeah, anyway, let's just get these caps off. I'm going to use the 2 soldering iron technique. That's pretty easy to do. Just fly through these, get rid of all of the caps in one hit. And because this is going to be a speed run, I want to show you 1 or 2 of these. So yeah, we'll heat. Hang on, let's just add a wee bit of solder first to that side and that side. Yeah, just adding a fresh bit of solder, you know, containing flux, just can help things flow a wee bit better. And then yeah, we'll heat that side and heat that side. The Antex, this one here, the yellow one, is not really heated up as thoroughly as it could be at the moment. There we go. And just do that, you know, you can just flip them over. I'll collect those, we'll measure them afterwards, but pads look okay there. I'll just show you 1 or 2 more of these, just move the board up a little bit. Let's do some of these. I'll try without adding solder, let's just see how we get on. Yeah, so it does take a bit of dexterity because trying to use 2 irons at the same time. Yeah, there you go. May not be everyone's thing, is the point. Let's try and come in at a slightly shallower angle there. So you can see it's going to take me approximately 7 or 8 minutes, maybe 10 minutes to get all of the caps off. And I've got a piece of paper that came with this kit. Show you that later. That's got positions of all the caps, so it should be really quick and painless. This. Yeah, so on mine here, these 2 have definitely leaked, and the green stuff that's on the board there is just making it a bit hard to get some solder onto the point. So I've just scratched with a pointy, you know, a sharp tool here, the actual solder point, and there's lots of crystallized stuff come off the surface. And we'll try again with some flux and solder, just see if I can tin them up, because when I can tin them up, then I'll be able to heat with the iron and remove without an issue. Yeah, there we go, got a blob of solder on there now. And again, I'll try and show you me removing these. It's really not hard. You don't need to put a lot of force onto the board at all. You just need to just make sure you've got the iron sufficiently hot enough temperature and that you're on the actual solder points. Yeah, this one's going to be harder because of the corrosion. There you go, it's moved, look, just lob it. So, yeah, it's not... Yeah, the hardest bit is just having the dexterity to use your left hand if you're not left-handed. You can see they come off really easy. Doing spec, well, that one's stunk, so that one's leaked as well. I think all three of the 100s around there had leaked. The 47s look alright. Let's get rid of that 47 next. Yeah, do inspect after you've done a small batch like this, just to make sure you've not got solder where you don't want solder. There we go, see, it's easy. Yeah, last one here now. It has taken me about 17 or 18 minutes, because one or two, like this one here, I did have to just stop, scratch the surface, clean with IPA, because they've leaked. I would say several of these have leaked, which is interesting. When I repaired this, I don't know, 3 or 4 years ago, it might be 5 years ago now, the caps were alright on it actually. So yeah, over time they have worsened. I'm not sure the solder's biting on that side, so let's just see, is it going to come off? If you struggle after maybe, I don't know, 20 seconds or so, just stop, clean the pads up with something like my scratchy tool, there we go, clean with IPA, and then try and add some more fresh solder and flux, and it should come off like that. Yeah, and I thought that was the last one, and it isn't, but it gives me an opportunity. The pad on this side here is, you know, solder is not flowing on it, so just scratch the solder around there like that, and cotton bud with IPA. You will get solder where you don't want it, and generally, like up the side of the cam, so just be careful, inspect around each one as you've done it or when you've finished, and just make sure you've not got any rogue particles of solder anywhere you don't want them. Wait till you get the temperature, flip it up like that, dead easy. And we lost 0 pads, and each cap had a tiny bit of heating in order to get the cap off. So unlike the A500, the 2000, etc., these are machines that I would always recap. If you own one and it's never been recapped, it needs recapping. It will just be a matter of time before your machine dies completely and you regret it. So yeah, a little bit of flux onto the braid. This braid does have flux built in, but I always had a bit of dedicated. And I'm just going to just clean up each of the pads where we've removed the cap here. Minimal amount of heat, just enough to absorb. And then I'll just clean with a bit of IPA. And I'll do these as I go along, just to clean the pads up so they're all ready. There were some places like that where there was a position for a cap, but there wasn't one there. So yeah, just pay note to things like that. You know, if you were to remove the solder from there, you could confuse yourself and think you're missing a cap. And technically you are, but it was never there to start with. Yeah, it needs cutting back a bit, the braid. You know, to solder braid, as a capillary reaction, the solder will suck up so far, but then eventually you get to the point where you have to cut it back. Or use it further back, but then you get solder everywhere if you're not careful. Yeah, its capillary reaction will stop, you know, working as well as it gets saturated with solder. Anyway, you get the idea, so I'll perhaps report back when I've done this. Right, so that's all the caps removed, all the solder rods removed. Got to swap that out as well, and obviously there's one or two through holes. These I'll just leave on because those are good ones. Brand new Panasonics I think I used there. But all of the solder has been removed from the pads. If we look at that in the light there, yeah, it looks very dirty, so we'll clean up with some cotton buds and IPA, and I'm going to get the fiberglass brush around here where it's a bit greeny. Also up here where one or two leaks as well. Anyway, I can show you that in a second. So this is one of the parts I like, the cleaning up bit before we fit the replacement caps. Just gently clean initially with IPA. Where we've got the corrosion, I'll then go over with vinegar and the fiberglass brush and IPA again. We'll just do that, you know, rinse repeat a few times wherever the corrosion is. So over here, I'll show you that. Don't press too hard, because if you snag a bit of solder on the edge of the pad, you could pull it off if it's a bit loose. Yeah, I think I removed one from there actually, but we'll do that when we come to it. So where we are here now, this is where there was a reasonable amount of corrosion actually. I think I would reflow that 3-pin device there. So super macro around here, can you see? There's little ferrites have got green pads, and that little 3-pin device there has got green pads and the resistor. So yeah, there's just a wee bit of corrosion around there. Just have a scan around. Most areas look okay, I think. Yeah, so the 2 pads there look okay. As we get further up here, yeah, a little bit of greenness around here, I think, just around 1 or 2 components. So yeah, let's have a scrub with the fiberglass pen, and then treat with a little bit of vinegar, and then rinse off with some IPA. It'd be hard to hold this stable, but I'll just show you a little bit. It's just a case of having a gentle wipe around here, and then, as I say, get some vinegar and a toothbrush and brush around, then have brush around with some IPA. Yeah, so that's all I'm going to do, is just have a quick clean on the surface of these things here. So a wee bit of vinegar here, and if we just have a clean around, you should be able to see it come up a lot cleaner. It's going to be way better when it's been toothbrushed. I will just get a bit of flux on that 3-pin device and reflow that, but hopefully you can see it's coming up a lot better around there. And this area looks an awful lot better at this point, and I haven't needed to reflow anything, so I've just got some IPA on the toothbrush here, and I'm going to start actually from right up here, because I've cleaned this area just around here. It's needed a clean since I got it, this board really, but yeah, it didn't have these greeny points that we're seeing, or what we did see in this corner. I mean, it didn't seem to be affecting anything, because the video and audio was fine, it was reliable in terms of booting, and it was fine at reading discs. Maybe a bit sulky on some CDR, but you know, original discs, no issues at all. So yeah, anyway, you get the idea. It's just a case of using a few different caps of IPA like this, have a bit of a scrub around the area, and then finish off by pouring a couple of caps of IPA right down the board like that, and I will do a few, clean the brush, give it another brush again, and just do the same with a few more caps of IPA. Anyway, that's that area, I think, as clean as I would like to get it. And of course I can do this after I've done the recap work. It's always worth comparing to a diagram or something, and I'll show you a cheat sheet here which will help me get these on really quick and make sure I get them in the right places. So 100 in like sort of an L sort of shape. Yeah, the key here is really using magnification, because then you can, well, see better what you're doing. If we just get onto the pad, Try not to touch the cap, introduce the solder. Copious amounts of it, because I'm not sure that's how it is flowing. Yeah, if you get a big bead like that, remove all the solder from your tip. Just hold the cap and just reflow it to a small point, remove the solder, maybe just heat it again. And of course if you had some separate dedicated flux, you'll get a cleaner solder point perhaps, but I'm using solder containing flux here onto the pad. There we go. Yeah, so hopefully you can see we got the 2 solder points done on that one. I just reflow it maybe for good measure. Yeah, so 4 down, about 40 or 50 to go, I think. So that's most of the board. Yeah, most of this area here done, so we're just finishing off now. There's only about, I don't know, 10 or so caps to go back on. Yeah, if you want to see a more in-depth video, check out the link up there. This is just a kind of vlog-ish video for the reason that, as I said, I've done 2 of these before. Alright, that's it. I am all done. Well, apart from this one, I'll swap that one now. But it's been pretty uneventful. The only one I haven't done, and the one I don't want to do is this one here, this tantalum. Just because I know tantalums fail, but generally not on these. I could just keep the spare. The worst that can happen is it shorts and I lose a power rail. Yeah, maybe something could die as a result of that, but it's a lot less of an issue than these at the caps here leaking. It's the same with these actually. I mean, those you generally swap because they're usually the wrong way around and they'll have leaked. But like that one there, you could just leave it. But yeah, I am gonna swap it whilst I'm here if I can work out where. If I can work out where the solder points are. I think it's these 2 here actually. Yeah, so let's just get that off. Yeah, so it's these 2 solder points here, isn't it? Might be one of these where I need to pull it through, to be honest, because the tip is tiny, and mind you, it looks like the solder's removed there. Most of it has. Yeah, it's going to be easier just to pull it and then block the holes, I think. So if we just heat, sometimes you can just wobble it like that, that's free. But if there's lots of solder there, that won't work. You're best off actually heating. Wait for it to get molten. There we go. Yeah, I'll put the temperature back down again in a minute. Yeah, so the positive markings on the right here, I blocked it from the top side. That proved to be a bit easier. And I tested that the left side here is ground just by testing a connection to here. So yeah, the marking on that is correct. Let's just bend the legs out a wee bit. And again, I've just got the higher temperature here just for the moment, because otherwise it will prove difficult to get the solder to flow all the way through. Yeah, that'll do for that pin. It's held in position. And that pin is a wee bit easier to solder. The telltale sign is feel the cap on the underside. You can feel the cap heat up really quickly when you heat that pin, but not as quick when you heat that pin. And when it starts to get hot, you know that's it, the heat has passed through. So other than just having a spot check around the board and cleaning up the solder points there, I'm just going to reflow those. I always do when I've cut legs like that, because you just get a cleaner to a point. Yeah, we should be good to go. And if you use too much heat for too long around an area like that, you could mark the board or end up losing the pads if you're not careful. That capacitor, incidentally, was an FR series. It was part of the kit that way. So yeah, he's used some good quality caps for sure. And in case you're not aware, when you're looking for caps for something like this, if you want to source the components separately rather than buy a kit, have a look on somewhere like DigiKey and it will list the number of working hours a cap is rated for. Because they're not all the same. You know, you pay more for a cap that'll last 5,000 hours or 10,000 hours or, you know, more than that, etc. Sorry, that is at a certain temperature. So like they're rated at like 5,000 hours at 105 degrees, for example. Well, that's going to be a blooming good cap compared to one that will only last 1,000 hours or 2,000 hours at 105 degrees. So it's just something to think about. So inspecting all around there, no issues. I'll clean up the edge there in a second. But yeah, hopefully you can see it's super clean and tidy. No issues at all, no corrosion, barely a mark on it. Just the connector there needs a clean. So let's try and get it into the shield here. The key here is the opposite of when we took it apart. It's getting these things through there like that, and then gradually getting the board into the shield here. Incidentally, look, that's broke off. I knew that was going to break off. It's not a big deal. Yeah, that's it. So the board is in. Let's get the case back down there. And set it into position. I think we'll power it up that way actually. Let me just connect the power and video and stuff. Yeah, so I'm just going with composite here for the moment. And in fact, that's like the only connector you've got on the back, unless you have, you know, something that connects to there, which we do have. And I'll try that in a minute. We'll try it with the TF330. Yeah, so bear in mind this is composite. We don't have the drive connected. That's a good sign, I think. Yeah. Sweet. Yeah. That looks pretty clear, to be honest. It doesn't look much clearer than it did before, but maybe a little bit. It's nice and sharp. The composite on the CD32 is really good actually, but of course you can use S-Video. So now we know it's booting, let's just get the piece of shielding back on and the screws in, I think. It's probably a good idea to always disconnect power when you do things like that actually. In retrospect, just go hook the little things over there, and I just leave these up, as I say, because I'm going to leave, that one has to go down actually, and that's going to break off actually. If you just bend this over, it's going to break off probably. No, it's not doing. It will do after one or two more bends on that. Yeah, I mean I could heat sink some of the chips in there, but I'll be honest, I don't use the CD32 that much generally. So again, that's something to consider. You know, do you want to use your CD32 a lot? If you do, then heat sink some of the main chips like Alice and a Kiko maybe. But I tend to use, you know, the 2000, the 4000, the 500, etc. a lot more. This is kind of, you know, just a luxury thing for me. Every now and again I'll have a tinker for half an hour or an hour on it. And it doesn't really get that much opportunity to get too hot. Yeah, that wasn't on quite on there, that's it. So yeah, my shielding is a wee bit rusted and stuff compared to some of the units out there. So finishing up here with a bit that I absolutely hate, and that's lifting this flat flex. Why did they not create the shield a little bit bigger gap here? It really bugs me, this thing. You lift it up on one side like that, and then try and, as I said, hook onto the other side. Yeah, that's coming up, but then that side's gone down, seesawing now. It's just near impossible, it seriously is. Right, my one original CD32 disc is booting. As you can see there, it's Robocod. It's a bit scratched up, this disc. This came from Graham over at Riot Retro Gaming. Sadly, those guys don't really do any videos anymore. I wish they did. I know they're in different areas of the country, but they could sort of link up and stream. Yeah, so any like artifacts and things, that's just a result of scratches on this disc. But I think the game should work actually.
Somewhere deep below the ocean waves lies the top secret headquarters of SI-5H. Reporting for duty.
Yeah, it's a bit scratched, that disc. Let me connect the TF330 up now. Now that I know the drive's at least working, we'll try the TF330. So here's the TF330. This is one that was fully assembled actually and donated by Super Duper. So thanks ever so much, Mark. So I've used this quite a bit and I love it. Yeah, so ESD bag there, it's a bit bodgy, isn't it? And we just need to carefully try and slide it in. In fact, we don't even need the lid on for this, do we? We can just lift the lid up and then it makes it a bit easier for you to see what's going on. Yeah, just sit it in position. I never cleaned up the edge, did I, the connector? I'll have to do that next. And then get it on, like, hang on. What's going on here? What am I sticking that into there then? Yeah, it can be pretty hard. There we go. To align it with the shield and stuff. You can see it's got these little pad things that hold the board up here, so it's not going to short onto anything. Just pull that up a wee bit further and put the lid back down. I think we'll just we'll take that disc out as well. Just power it on, and it should boot hopefully from the TF330. And from memory, it boots pretty blooming quick actually. That's assuming it's going to work. Oh, yellow screen. Oh, that's not good. Let me try reseating it. I hope it's not going to keep giving me a yellow screen. No, let me try cleaning up the edge connector and reseat it. Yeah, so it's always a bit traumatic when things like that happen, because you're left wondering, have you got a fault? You know, have I killed it? Maybe the TF330's got damaged or something. So a cotton bud with IPA. Let's just get in between the shield and the connector there, and easy said than done. And the underneath one as well. Just for good measure, we'll reseat that there. And get it back on. Let's try that. Now it could be a case of low 5V level actually, because this power supply has been giving me some jip. I'm just using the ATX power supply, and I've got like an extension here that goes to one of these Molex things, and I'm getting some voltage drops, so you never know, it might be that. Oh, there we go, it's booted really quick as well. So it was just a dirty connection, I think. This TV's doing that thing again where it's half height, and that, obviously it's the composite that's confusing it here. And in fact, I'm not sure why I'm messing around with the composite here, because the back of the, I'll switch it off here, the back of the unit there now has RGB via the backplane thing. So we'll just connect the RGB cable up. Still need the left and right audio connector. Yeah, that's on SCART now. Fantastic. So I need to connect a mouse up. Let's see if any games work on it. Actually, this is the Atari port, isn't it? The god awful one. Hence the terrible music. Come on guys, the Amiga could have done better than this. Got a freeze there, haven't I? I think this is just the glitchy Rev 2 TF330, to be honest. Okay, this is gonna go. So I decided to do two more things to this. I am going to swap out that cap. I'll just use both irons to remove that tantalum. I'll show you that. We'll swap that. And I'm going to heat sink Alice. I forget where Alice is. Lisa and a keycard. I think it's these three here actually. And I don't even need to take it out of the shield here because I'm not using hot air or anything. So yeah, I'll just gently wipe the top of the keycap, and we'll do the same thing with Lisa and Alice. I don't think Lisa needs heat sink particularly. You know what, the Akiko may not need a heat sink, but I'd like to just try provide a little bit of extra heat sink in there. There should be enough room under the shielding. It stands up quite high. That's it. Yeah, trying to get it as central as possible. And you could have You could argue maybe try and fit a fan inside there, but it's just going to introduce some noise probably. So with tantalums, I think the band, as you can see, it's pointing down towards the joystick ports here. That indicates the positive rather than the negative. I always found that confusing. I think that why tantalums would be different to other capacitors, where the the band here designates the negative, although it might designate the positive on SMD ones. You know what I'm talking about? I'm talking about the stripe on the side of an electrolytic can that indicates the negative. So I'm shedding a bit of solder to each side there. Hopefully the antex is warmed up, because yeah, this iron is not temperature controlled, and whilst it doesn't provide very much in terms of heat and wattage, it takes a while to heat up. There we go, it's off. It's upside down, that's good. They kind of seem to nearly always fall upside down when you lift it like that. Yeah, so I've cut the braid back a bit. I'm just going to use the antex again just because it's out. And absorb the solder. In fact, I'm not going to absorb all the solder, because you know what, it'll make it a little bit, yeah, it'll make it a bit easier to get the other cap on. We'll just use a bit of the solder that's already there. It's leaded solder, so yeah, it's kindly packaged in a little package like that with the parts thing written on it, etc. Yeah, these kits were just amazing. I've still got two 1200 kits that I want to keep. I think one of them may be for Novabug's machine if he ever wants to get that to me. Although I noticed Novabug's been selling some of his stuff actually. He just got rid of a 3DO. Maybe he's selling his Amiga. Yeah, so the band to the right here, it's just now a case of trying to push it towards that, and then I'm simply going to slide it into position as I heat it here. So we'll just wait for it to pull itself into position. I think what I'll do is just, yeah, you'll not be able to see, I'm just going to press down as I reflow, just to make sure it's flat, and it is, and it's pretty straight and equidistant there. So let's just add a wee bit of solder down there. That's it. So I just need to clean up with cotton bud and some IPA, but yeah, that's all of them. Yeah, just measuring some of these electrolytics here, well, all of them. Hang on, go through them all, and I'll show you the reading. 20 ohms, so yeah, it's turned into a resistor. And these are even the 47s that hadn't actually caused any leakage anywhere. Yeah, turned into resistors. I think we're going to see the same thing with the same size of caps, if you see what I mean. So like, I think the 47s are all, none of them are leaked, but they've all gone. Yeah, I mean, some of them are measuring like that. Some of them are measuring like that, open circuit, low capacitance. Got to show you this one. It's the first time it's been my meter make a sulky noise. Hang on. Did you hear that? First time I've ever heard that noise from this meter. Yeah, it's like very wrong. Greater than 40 ohms. Good God. Yeah, so most of those were what I would say is out of spec. 3 or so of them were over 40 ohms, and there were 2 or 3 that were around 22 ohms. 2 or 3 around 5 or 6 ohms. So yeah, it's a good idea that I swapped those out. The interesting thing is, I used this meter when I first got this and tested them in circuit, and there were no issues. So, but it's 5 years ago since I got this, so yeah, it hasn't had a lot of use. It's been sat around, and you may think that's not an issue, but systems, when they're not sat around, it can have a bearing on capacitors, because there's no charge in them. They're sat in a discharged state. Yeah, I read something about that. I can't remember exactly the in and outs of it, but if we test this here, hang on. Yes, this is one of the through-hole ones. Yeah, double ding. This is the thing, you know, a wet type through holes like this. There's nothing wrong with that. Didn't need to swap that out. 470. It's a bit low, but it's probably within tolerance. It is a Shui though, and those Shui caps, yeah, it's always a good idea to swap them. But the ESR and the capacitance is okay on that, really. Perhaps a bit low on the capacitance. Right, so here we are back in pieces again. It's working fine. Well, I say it's working fine. It's super sulky with the TF330. I have cleaned the edge connector up, cleaned the adapter, I'll show you that in a minute, you know, the backplane thing. So many times, reseated it. What happens is the power light stays dim, like it's not received the reset. And then I was messing around with the jumper on the Terrible Fire, you know, the disable pin, and that seemed to make it work. Like, you'd slide up and down a few times, flip the power on, and then it would work. And you could power it off and on 20 times and it would work every time. And then you'd change that jumper, or move that jumper around again, and then it would stop working again, and then I changed the jumper for a new jumper and it wasn't working. So I'm like, is it the jumper, is it the slot? I was like, I've gone round and round and round, and I remembered we got this little bit of corrosion here, and I did clean up around here thoroughly. You can see that it looks really nice and clean, but I didn't reflow that, and that is responsible for the reset. Might need to swap that. It might be another video, we might do a revisit. So I'm just going to get a wee bit of flux onto that and reflow the 3 connections there. For good measure, we'll do the one on the back of it as well, actually, the tab. And then the other thing I'm going to do while I'm here, you could argue it's pointless, but I'm going to do it anyway. Yeah, the missing capacitor down here, I looked at the schematics, it's supposed to be a 10 microfarad one, although it's not marked on the schematics as 10 microfarad compared to the 1200 schematics. It's on the Paula supply rail, and it's got the same caps as the 1200, except for that, they removed it. So, I don't know if it's a cost-cutting thing or what. I'm going to fit a 10 microfarad cap on there. And the reasoning is, looking at the schematics, I see no reason to not have that cap there. And if it's good enough for 1200, why is it not good enough for the CD32? Yeah, the CD32 is basically a 1200, so anyway, yeah, these are quite small. I think I dropped it, so blooming small. So they're tiny, these. I've recapped Mega CDs with these in the past. But it's the right voltage, 16 volts, 10 microfarad. Right, the cap has been soldered into position. It may go out of focus here. I'm just going to heat these and reflow them. Yeah, the solder is not flowing very well there. What I may need to do is use the braid here. Let's just try that actually. And I really should be using magnification for this. I'm just going to bridge them all at this distance, aren't I? Anyway, I'll report back in a minute when I've removed the bridges, reflowed it and cleaned up. And there we go, reflowed. So hey, I'll give you a quick hover around the caps, because this is going to be the last time, hopefully, that I'm inside this. Yeah. And you can see where I fitted the additional 10 microfarad cap on Paula there. So the main lighting's off at the moment. You can see this lovely cheat sheet here from Retro Bench. Yeah, Amiga CD32 capacitor guide Rev 4.1. There's obviously some really nice notes. I'll just give you a close-up on this. It might just help you out. It's really cool. They went to this level, really. You know, showing where the negatives are on those caps there. Those are the ones that are often the wrong way around. You can see those in the 3-part original repair series. I did, there'll be links down below for that. And you can see the band on each of these as well, so you get the polarity right, and obviously the colour coded. So yeah, and then at the bottom here you've got a table that, you know, explains what size and voltage ratings and things the different colours are. Pink and red, it's a bit easy to mistake, you know, you can see that's red, that's pink, but nevertheless, yeah, that is really cool. And on the other side you've got the guide here for Rev 3 and Rev 4. So yeah, subtly different. Again, just have a quick scan around that. Yeah, and I thought I'd just quickly show you the CD32 schematics there. So you can see at the bottom there's a cap with an X or something next to it, which kind of indicates they were going to stick it there, and then went, nah, we don't need that. Now it's important to note that sometimes capacitors can be removed for a reason. So it might be that, you know, you just got a little bit too much decoupling there, a bit more, you know, it's holding some power as the power goes off, and you've got a voltage mismatch somewhere where one's part of the circuit has got a little bit charged, still in a cap that you don't want. But I don't think so, not in this case. I just think it's a cost-cutting thing, really. So, interestingly, I worked out the issue that was causing this to hang, where often the power light would just be dim. Yeah, it wouldn't never get to the bright state as if it started to boot, because that's one of the things that happens very early in the boot process on the Amiga, as it runs through the kickstart, you know, code there. It changes the LED here. It's one of the very early things it does. So if you don't see, I'll show you. If you don't see the power light go, it'll be dim. Watch, dim, bright. Yeah, if you don't see it go bright, it hasn't even started to boot. Yeah, and that was a common thing with this, and it was one of the reasons why it kind of prompted me to recap this on the back end of the FMV video. But nevertheless, at the end of the recap process here, it's doing exactly the same thing with the TF330. It's driven me to despair. I should have filmed some of this really, but anyway, I tried a different one of these risers for the back here, made no difference. Reseated and reseated and reseated, cleaned up the card, cleaned up the slots, cleaned up the motherboard, edge connector, reseated, so many things, messed with the voltage on the power supply, because if you saw the FMV video, there'll be a link up there to that, you'll know that I had a bit of voltage drop, and still do with this. It's like 4.7-ish volts at best. Doesn't matter how much I clean my, you know, the DIN here, doesn't matter how much I clean the power switch, you know, switch the thing off and on, it's a bit spongy, that power switch. That's the problem. I think it needs a new power switch. I can't get more than about 4.7 volts, so I was like, is it the voltage? And then I was finding, you know, I could press on the back plane here, switch it on, oh hang on, it's working. So I was like, oh, it must be the back plane, so I've messed around with that again. No, it isn't the back plane, but I'm like, well, why when sometimes I push it, does it start to boot? Yeah, and then the next thing is I took out the card and I messed with the jumper for the enable disable. And whilst the lid was off, I was like, slide that jumper up and down, switch it off and on. Oh no, it's working. I was like, is it the jumper? So I changed the blooming jumpers, like, and then it would work all right for an hour or two, and then suddenly it's not working again. I messed with the jumper, and then it wasn't working. So I'm like, well, is it intermittent? What's the issue? I reflowed with hot air. Let's just take this out. Yeah, I reflowed with hot air, the CPLD, the RAM, the 7.4 series on there, and it's still doing nothing at all, like mostly not booting, just not able to work out what on earth the cause of this is. Bear in mind, it's been recapped now. So I was like, well, maybe it's a dodgy chip, or I don't know. And then I looked at the crystal here, and you are not going to be able to see this now because I have just fixed it, and this was the issue. This was the issue with my 330 here. So nothing to do with the recap work or anything like that. This crystal here, if you can just about see down the sides of it, the solder points are going up the chip there, because it is a chip, it's a 4-pin, up over the gold points that you can usually see on the sides of these, on all 4 sides there. The way it was, there was gold, you can see gold up the side, gold up the side, gold up the side, gold up the side. So in other words, the solder, when it was originally applied, it was underneath, barely making a connection. It was that crystal. That's all it was. That's why it was failing to boot. It was got nothing to do with the power supply, nothing to do with the connector, nothing to do with the, you know, voltage drop or anything else here, or even anything needing reflowing. It was all about this crystal. I had a bad connection on this ever since, because this has been intermittent ever since I got it, and it's always driven me nuts, and often just like disconnect, reconnect, disconnect, reconnect. Suddenly it start working. Yeah, it may hang at some point. You're like, why is it hanging? And again, disconnect, reconnect, disconnect, reconnect. It would start to work. It was that. Yeah, it was definitely that. I'll show you this now, because all of the times that I've messed with this over the last week, following the recap, I would do something as simple as this now. You know, this is nice, clean, reconnect it, and expect that it should work because it's all nice and clean. Let's just put the bag around that. We need something better than that at some point. Yeah, feed it back in. And what would happen is, literally, you could do this 30 times, and every single time, there's no way it would ever work on the first insertion like that, yeah? Noting that everything's clean. This would not work at all. Watch, switch it on. Oh, hang on, power switch is off. Yeah, sometimes with this HX power supply, oh, and it's not plugged in. Yeah, it helps if it's plugged in, doesn't it? Switch it back on. Oh, hang on, that needs switching on. There we go. There you go, dim bright. It's booting again. And if I point you with the screen, I'll do this all in one cut. Yeah, just hit the CD. It's now starting to boot from the hard disk. And it doesn't take very long because it's so blooming quick. There you go. It's solid. Absolutely solid. So yeah, just a bit of a bonus thing there at the end of this recap, that if you do get problems with some sort of card like I was experiencing here, just run through the motions really, you know, check all the cleanliness of the connectors and the slots and things, but do, you know, consider reflowing certain things on there. In my case, it was just the crystal. I think I got that card from Super Duper actually, so I'm very grateful. It's just one of those things really, that crystal, when it was assembled, he probably did that in a hurry, but you can see it's every single time. This was not happening. It's so stable now, it's so robust, and I do have voltage drop still, so It's interesting as well that these will run even at 4.7 volts. It's quite happy, which I find amazing actually. It's amazing that the chipset on these is quite tolerant at around 4.7 volts. And I've been using this for a few days now. It's absolutely solid. So yeah, it did need the recap, but the instabilities that kind of prompted me to do this, the glitching, which I'm not sure I captured, and then it may freeze or reset. Yeah, and it was that crystal. It was just that crystal. I was just copying some files from one drive to another. This compact flash card was originally set up by someone else, I think. It was the card that kindly came with this from Super Duper. Yeah, as soon as that's finished, I'm going to test out the TF328, is it, I think? Yeah. So this is IDE plus 8 meg, I think. So that's quite cool. I've got a separate riser for that. I've got a few of these now, because I've got another one there that came from Mark, Super Duper as well, an early one. Which got these connections here where you could stick a PCB or something on there to break out the video and things like that. Yeah, and I think I remember sticking this ESD bag on here with double-sided tape. Later ones had little holes and things punched out. It was quite nice the way those ones are done. I mean, you can sort of see that here if I just hold this. Yeah, you can see he's used the holes there, and then it grips the plastic. So quite nice. It just isolates, so you don't touch the pins there at the back. But whilst I'm here, I'm going to test these things anyway. Test these other two risers. Test that card. Make sure that's working. And just for good measure, I've had the 330 in and out a number of times, and every time I put it back in, it insta-boots. It works first time. So yeah, it was just the crystal, 100% the crystal. So even though the state of the capacitors in this, that was not causing me any issues. Glad I did it though. I'm glad we have recapped it. But at least you get to see just one or two of the little bits and pieces within this video. I've recapped them a few times now. I just stuck a label under there, recapped 2023.